Closed doors, I'm a fool for your love. Closed doors, I'm a fool for your love.
Hey guys, today we are discussing the chapter 8 subnetting IP networks. So this chapter is coverage by designing, implementing, and managing an effective IP addressing plan ensure that network can operate effectively and efficiently. This is especially true as a number of host connections to a network increases. Understanding the hierarchical structure of the IP address and how to modify the hierarchy in order to more efficiently meet routing requirements is an important part of the planning IP addressing scheme. So this is the broadcast domain. Is an Ethernet LAN devices use broadcast to a locate. This is the example of broadcast domain. This is the router one. This is the internet. This is the switches. So a device use resolution protocol or ARP which send the layers to broadcast to known IPv4 address on the local network to discover the associated MAC address. So the services. Services a host typically acquires its a IPv4 address configuration using the dynamic host configuration protocol or DHCP, which send broadcasts on the local network to locate a DHCP server. So for the reason or subnetting, this is meaning of the topic. So let's discuss. This is the LAN 1, LAN 2, LAN 3, LAN 4, and the LAN 5. Locations such as the floor and the building, the figure 1. Organizational unit, device type, any other division that makes sense for the network. So this chapter describes how subnetting is performed. Understanding how to subnet network is a fundamental skill that all network administrators must develop. Various methods has been developed to help understand this process. This chapter will focus on looking at the binary method, although a little overwhelming at first. Focus and pay close attention to the details, and with practice subnetting should become easier. So subnetting the octet boundary. This is the subnet address. It's a 256 possible subnet host range, 65,534 possible hosts per subnet broadcast. So this is the internal network address. This chapter is to understand the subnetting the octet boundary can be useful. Consider the following example. This is the example. The figure 2. This is the 65,536 possible subnets, 254 possible hosts per subnet, and this is the broadcast. Did you see the difference in the figure 1 and figure 2? So let's wait. The internet is so very slow. Classless subnetting. The examples in so far borrowed host 24 bits, which is the 24 bits for common 8, 16, and 24 network. You see this the plus 8 However, subnet can borrow bits from any host bit's position to create other masks. So this is the prefix length subnet mask in binary, number of subnets, number of hosts. So this is the number of subnets. Can we see they multiply itself. For example, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and 32 times 2 is 64. They multiply by 2's. And this is prefix length. And next, so video demonstration. This is the video demonstration.
Point out that subnetting makes sense from the binary perspective.
Can we listen?
In other words, when we take the IP address and the subnet mask and convert them to binary, I have the IP address on this row here, I have the subnet mask on this row, converted to binary, that the computer and the router are able to logically AND or combine the IP address and the subnet mask and find the network address. In other words, this ANDing process is a logical process of ANDing. So a true and a true makes a true, 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 false and true makes a false. And if we do that and logically AND the IP address with the subnet mask, we get the network address. So 192.168.1.10 logically ANDed with 255.255.255.0 produce.
So this CCNA study guide chapter 8 summary. This chapter began with an introduction to routing, including look at the difference between the routed IP and IPX and routing RIP and IGRP protocols. The combination process of a simple one router network was described step by step and included an overview of the different processes that takes place when a host on one network attempts to communicate with a host another. A more complex example involving multiple routers that the network demonstrated the way in which a router will forward packets to the next hop address in the journey between a source and destination host on a different networks. A look static routing provided an overview of how a technique allows an administrator to manually define the path that the router will choose, reaching network that included a look at the IP routing table and the syntax of the IP route command. The concept of administrative distances was also introduced in order to illustrate how a router makes decision on which routing table entry to use when a path to the same network learn in the different ways. For example, a static routing table entry will always be considered most trustworthy than a route learned from a routing protocol by default. A dynamic routing demonstrates how a routers are capable of exchanging router to table information with another boot through the use of distance vector and the link state routing protocols. The major difference both types of routing protocols were outlined as was a concept of a hybrid protocol. The danger of routing loops was also discussed, including a look of the techniques used by distance vector protocols to avoid these loops. The IPX routing was a look to the next, including to the fact that IPX, RIP, and SAP messages are broadcast between routers automatically after issuing the IPX routing command. The IPX routing table was looked at to, as where the commands to monitor IPX, RP, and SAP broadcast traffic. The show protocols command outline a quick and effectively way to obtain information on router interface, including their current state and configure address. So this is the summary.
Behind closed doors, I'm a fool for your love. Closed doors, I'm a fool for your love.